Chapter 8, Section 2 is proving triangles similar using AA, which stands for angle, angle. So now we're taking similar polygons and narrowing it down to just triangles in the next two sections, today's section and in 8.3. You're going to learn 3 shortcuts. This is the first of them. So just like we learned shortcuts to proving triangles were congruent, you're going to learn shortcuts to proving triangles are similar. All right, so the first shortcut is called angle, angle, focus, folks. Angle, angle similarity. The biggest and most important thing here is this is not just AA. You can't just write AA as in a reason. It is angle, angle similarity. So we will abbreviate it to be like AASIM to show similarity. But if you are giving a reason why two triangles are similar, you cannot write AA. So angle, angle similarity is a theorem that says if two angles of one triangle are congruent to two angles of a second triangle, then the two triangles are similar. Again, not saying they are congruent, so they're not the same size. They are the same shape, all the sides are proportional, and all of the angles would be congruent. We already know 2 pairs are congruent, but because they're similar, all 3 would be. So in the diagram that's there, angle A is marked as congruent to angle D. Angle B is marked congruent to angle E. So these triangles are are similar, which again is this symbol here, similar. And the reasoning would be angle, angle similarity. So by the time you take a quiz, you'll learn 3 of these shortcuts. Today's just this one. All right, so example 1 just says tell whether triangles are similar or not similar. And again, eventually we'll have 3 ways, but right now we only have 1. So if I look at the triangles in A.
There's only 1 triangle.
Well, there's a triangle, then a triangle, right? Because there's 1 triangle here, and then there's a big triangle. What information is given to you about these triangles?
They're parallel.
The bottom sides are parallel. So what do we know if there are parallel lines? What do I know about the angles formed?
The angles are equal.
Which angles are equal? So let's number these. 1, 2, 3, 4.
1, 3, and 2, and 4.
Why are 1 and 2 and... No, wait, did you say 1 and 2?
1 and 3.
1 and 3 and 2.
No, he said 1 and 2.
Okay. So why are these congruent?
Those 2 horizontal lines that are intersecting the triangle are parallel. Or at least the wrong.
Okay, no, he's not wrong, actually.
Parallel to the base.
So then, if they're parallel, why are the angles congruent?
Corresponding angles.
1 word off.
Corresponding angles.
Corresponding angles theorem. The corresponding angles just means they're defined as corresponding angles, right? The theorem tells you that those are congruent. Well, if this was a proof, let's say, and you just put corresponding angles, you would lose points. So I'm just trying to help you prepare.
Was it?
Okay?
Will you get partial?
Sure. There's a lot of hypotheticals there that you're actually going to get that proof and that you're going to get it wrong. So it's better just to assume we'll get it right. If those 2 pairs of angles are congruent, then these are similar. And the reasoning, again, the only one we have as of now, is angle, angle similarity. Go to B. Are these 2 triangles similar? Yes. You explicitly have 2 angles that are set as congruent. 2 pairs of angles. Same thing, angle, angle. All of these are going to be angle, angle. And there's nothing that would even have to be proved there because everything would have been given. How about C?
Yeah.
Why?
Because the
Base angles.
Good. Base angles, or the isosceles triangle theorem, would tell you that if you use this big triangle and you ignore the line in between, that big triangle is an isosceles triangle, and in isosceles triangles, the angles opposite the congruent sides are also congruent to each other. So now if I go back to those 2 triangles, you've got 2 pairs of congruent angles, which would be a yes, and again, this would be angle, angle similarity. Questions on that one? Okay, D. So again, there's 2 triangles, the big one
No.
and the little one.
No.
Do they have 1 pair?
Yes.
Yes. this one is congruent to this one. And you mean a quadrilateral, the one on the right?
Yeah.
No, we're comparing the small triangle on the left to the big triangle.
Pay attention, Jonathan.
But we also said no, which is wrong.
Wait, what?
Wait,
I
what?
think it's right.
There's one marked, yes.
There's two triangles?
There's two triangles. There's one pair of angles that are marked, but is there another pair of angles there that's not marked? That would be shared by both.
Oh, yeah.
This one is in both triangles, right? So if I use the reflexive property,
That's like a trick question.
okay.
But how would you know that those two?
Why didn't you mark it then?
Because
You have
you'd
to do it.
never mark a reflexive angle, right? So this triangle would be similar to the big triangle.
Because they're both.
Again, angle, angle.
Can you use that trick for like all the time?
Yes. Yeah. Questions on these? All right, example 2 says to find x. So now we're finding a side measurement. As of now, we know nothing about the pairing of sides. But if I can prove these triangles to be similar, then what would be true about their sides?
There's a ratio.
You're on the right track.
Find the
There's
ratio.
the ratio of their sides would be proportional, yeah?
Yeah.
So if I can, 1, prove these triangles similar, then I can, 2, come up with a scale factor, and then I can find the remaining side. So are they similar? Yes, we used this already, right? The parallel lines would give me corresponding angles that would be congruent. So they are similar. So then the 2 triangles are this top triangle and then the big triangle. If you want to separate it out, you totally can. Like if it's easier to see 2 small triangles, this would be 3 and 5. And then the big triangle would be 4 because it'd be this whole side. And this whole side would be 5 plus x. So if you needed to see them separated out, you totally could. Based on that, what's my scale factor? Let's go little to big. What's the scale factor of little to big?
3/4.
3 to 4. So 3 over 4 is going to equal 5 over x plus 5. That whole side. So I get 3 times x plus 5 equals 20. Distribute 3x plus 15 equals 20. 3x equals 5. 5/3 or 1 and 2/3. Good. Kumar. Sorry? So eventually you will learn that because they are parallel, that works. But right now, that's not something. You have to prove they're similar first. Yeah. But that's that's 8/4, actually. And that only happens because they're parallel. Yep. Taken either of these answers. I can look too. I think if there's a fraction on the big ideas one, I can look and see if it wants
I
it.
don't know how to convert it. Actually, wait, I do.
You do 5 divided by 3.
Yeah, I know.
Okay.
I just have to make a little brain part.
All right. Example 3. I've got my triangle on the top right. I'm comparing ABC, which is what it gives you, to another similar triangle. So based on this, you have your parallel lines again, which we could say that the angles are congruent. And if the angles are congruent, these are similar. But it wants to know if the order of letters goes A to B to C, what should the order of the letters of the small triangle be?
EBD.
Good.
Well, we're not actually solving it.
Not yet. And the order is important. If you write that in different order, it's wrong. So be careful, okay? Now it wants you to find y. So what's the scale factor of the small triangle to the big triangle?
4 to 7.
Good.
4 to 7.
Scale factor 4 to 7. So then 4 to 7 would equal y is the bottom of this, or the side of the small triangle. That would go on top. To which side corresponds to y? 8. And then I'd get 32 equals 7y. Divide by 7. And y is 32 over 7, which is what, Mars?
A lot. 4/7.
Thanks, Mars.
Oh, you want me to change it
You're
out?
so
Okay.
smart, like I'm not talking to you, Tom.
Mark,
Shush.
impressive how your voice came
You
out of John.
4,
You have to, like...
32 divided by 7 would be 4, yeah? And what's the remainder?
This is a tricky one. It's 4.
It's 4. And what do we do with the remainder?
Put it on top.
Good.
See, I told you. I'm like a natural.
So 32, oh, Sunny's awake. 32 and 32 over 7 or 4 and 4/7.
So you don't have to do that, though, right?
No, I would take either answer. So either of these is fine. Is it important to know how to convert from an improper to mixed number? Yes.
Yeah.
But I'll take either one of those answers. Okay, so then B goes back to the side lengths. BE over BA would equal what? 2 side lengths. Give me, there's 2 pairs here. Yep.
BD or BC.
BD over BC and what's the other one? We just used them, right? What the Y and the A. So DE and CA or AC. And then the last one I want to find is X, and X is there on the right-hand side. Still 4 to 7 would equal the small side, which is 3, over the big side, which is not just X, it is X plus 3. And then we cross multiply. 4x plus 12 equals 21. Subtract the 12. And then divide by 4. 9/4 or 2 1/4. And again, either answer is fine. Questions on that one?
Yeah.
All right, so now we're trying to prove. And notice that the prove here is that the triangles are similar. As of now, we know only one way to prove that the triangles are similar, which is what? Angle, angles. So we know we have to get to the point in which we prove 2 pairs of angles are congruent, because that's the only way you know right now. Eventually, you'll learn 3, but for right now, that's all you know. So if I look at the diagram that's here, what's given to you is that AC is parallel to BD. That's given. So these are parallel, which then can lead to what? C equals D, and why is that? Oh, very close. Alternate interior angles theorem.
Not exterior.
That's one pair. Then what? You can do the vertical angles, or you could use A and B would also be alternate interior. So there were 2 ways to do it from there. DOB, you have to use all 3 letters because O is shared, and AOC, and that's VAT, vertical angles theorem. Or again, you could have done A and B using the same reason as step 2. And now they are similar. And that's angle-angle similarity. Questions on that one?
Can you just wait?
Uh-huh.
Me too.
All right, example 5 says a flagpole casts a shadow that's 50 feet long. At the same time, a woman standing nearby who's 5 feet 4 inches casts a shadow that is 40 feet long. How tall is the flagpole to the nearest foot? So if I have a flagpole, you've got a flagpole, right? That's 50 feet long. Nope, sorry, the shadow. This is my flagpole. The shadow is 50 feet long, so a shadow would be behind it on the ground. And at the same time, a woman standing nearby is 5 feet 4 inches, and she casts a shadow that's 40 feet long. So what you'd need to know is basically these could form triangles. You don't have to do this every time once you understand it, but these would form triangles in which the bottom left would be a right angle because we're assuming that they are both standing straight upright. And that the angle from the sun would form the same angle of elevation, which means these angles would also still be the same. Given those two, what's true about these triangles?
They are similar.
They're similar, right? So then 50 to 40 would equal the height of the tree, or the height of the flagpole over the height of the lady, 5 feet 4 inches. Yeah.
How would you know that the angle that isn't the right angle are similar to each other?
Because that's the angle of the sun. So when the angle of the sun hits anything, it's going to have the same angle of elevation.
How would we write that? Would we ever have to write that?
No, like once you understand that thought process, you'll know that when they give you something, and it's going to happen a bunch of times. It's a tree that's standing up. It's a flagpole. It's a building. It's a whatever. If it's a building and a shadow and another thing in its shadow, that those things will always form similar triangles. All right, so here's my problem, right? The left side, 5 to 4, which I can reduce, was in feet, right? And in the top I've got, or in the bottom I've got 5 feet 4 inches. So you basically have two choices here. Convert that to inches or convert that to 4 inches to a decimal of feet.
1/3.
Yeah, good. Because this says nearest foot, I would do the conversion of the inches to the feet, okay? So 4 inches would be how much of a foot? A foot is how many inches? 12. So that's why this would be 1/3, right?
Which is like 5.3.
Can't convert it to inches.
You can, but then you got to convert it back. One way or the other. You can do either. So you can either keep that as 5 1/3 x over 5 1/3, or you can keep that as 5.3 because we're going to round it to a nearest foot anyways. Because 1/3 would be 3 repeated. I'm going to do this again in inches, but so you can see both ways, but this is one way to do it. And then I'd cross multiply, so 4x would equal 5.3 times 5.
So it would be 4 after 40. Point and you're simplifying.
Yeah, I simplify. So 26.5, and then divide by 4. 26.5 divided by 4.
Can I use the restroom?
Sure. And my decimal is 6.62, which would round to 6.6.
Wait, why would it be 26.5?
Why would it be 26.5? 5.3 times 5. Yeah, there's the decimal. So that's if you converted it to feet. If you put it into inches, 5 to 4 would equal x over how many inches are in a foot?
64.
12. So in, whoa, 12. So in 5 feet, there's how many inches? 60 inches plus the 4 inches, so 64. And then we can cross multiply. 4x would equal 64 times 5, 320, and then divide by 4, and x is 80. But that's in inches, and you have to convert it back to feet. So I'd have to do that divided by 12. So you can reduce it before you divide, or you can divide. It doesn't matter which way you do it. But if I did 8 divided by 12, I get 6 again. And that time it repeats. So your rounding is a little bit off because in the bottom one we did 6.6 and in the top we did it would be 6.7. But it's asking for the nearest foot, which means I would round it to a whole number either way. And 6.6 would round to what? 7 feet. 10, 7. Yeah.
Do you think we would need a calculator on the quiz?
I don't think you'll have to convert back on the quiz. No, I know you won't because we have the quiz. The test we don't have yet, and I also know that you won't have a calculator for the quiz. Okay. You will, and I'll like remind you from here until we start chapter 9, but when we get into chapter 9, you have to have a calculator, and you have to have the one that we told you to get at the beginning of the school year. So if you need a reminder of that, like I showed you the picture of the one that you have to have that you need for chapter 9. So like in 2 weeks from now, you need that calculator. You can't do chapter 9 without a calculator.
I challenge that. Okay.
Questions on anything we talked about today? All right, so like 8-1, you're going to get an 8-2 divided into 2 assignments. The one for tomorrow is shorter, though.